Own Backup protects against data loss and corruption by providing enterprise-level control of data across all your Salesforce orgs from a single dashboard. Interactive graphs make it easy to identify Salesforce data changes over time, and automated daily backups protect your Salesforce data, metadata, and attachments. Manage proactively with customizable smart alerts that notify you whenever data is added, changed, or deleted. Quickly search your entire backup archive to find specific records, remove records individually or in bulk, and stay compliant with internal and external regulations, including GDPR. Compare backups at the click of a button to locate the exact point at which data was lost or corrupted, and recover lost data quickly, regardless of scale. With Own Backup, you can restore data records with their corresponding parent-child relationships down to any level of granularity. Speed up development with Own Backup Sandbox Seeding and Replicate to create anonymized test data sets in minutes, while advanced key management and access controls help to keep your data secure. Backup, compare, recover, replicate, and comply with Own Backup for Salesforce.
We were just a bunch of nerdy kids who ignored the haters. We took their ridicule and we built on it. And when some of us gave up, well, we built on that too. Built resilience, built on a mission to make things a little better every day until the users came. Then the haters were VCs who scoffed at our audacity. This just isn't the way things are done. But we kept building. Users turned into teams, turned into companies, running their entire businesses on our apps. Then the software giants came after us. We weren't proven, we weren't fully featured, our radical cloud model wasn't secure. But we built on. And today, as companies adopt the cloud to move faster, teams are finding themselves slowed down by each other's efforts. The skeptics are claiming we'll never develop innovation at scale. But now, DevOps have come to the cloud, ushering in a new era of transformation. Companies can release on demand across hundreds of environments, innovating faster with fewer conflicts and fewer disruptions. There will always be challenges. There will always be naysayers. And we'll build on.
All right, thank you everyone very much for coming to join me and talk about effective lifecycle management using portable automation and CumulusCI from Salesforce.org. I am really grateful to see everyone here today. I'm coming to you from sunny Denver, Colorado in the United States, so I'll wish everyone a good morning, good afternoon, good evening, wherever you are. Let me quickly introduce myself. My name is David Reed. I'm a senior member of technical staff on the release engineering team at Salesforce.org, the social impact arm of Salesforce. As part of the release engineering team, I'm involved in building the applications that I'm going to talk with you about today, and also applying them to the process of building and bringing forth to the community parts of our suite of nonprofit and education-focused products, including the Nonprofit Success Pack, the Education Data Architecture, Volunteers for Salesforce, Salesforce Advisor Link, Foundation Connect, and much, much more. My specialties are in platform architecture and packaging and best practices. I also focus heavily on Python engineering and automation for building complex Salesforce products, and that's what I'm here to talk with you about today. In my spare time, I try to stay active and engaged in the Salesforce community, so you can find me on Twitter at AerisDuel. You can also read my occasional writings about Salesforce at katema.org, and come join the community at Salesforce Stack Exchange, where I'm a community moderator. I'm going to make a couple of forward-looking statements today, so I need to show you this slide quickly. Please do remember to make your purchasing decisions based on functionality that is currently available. And let me quickly give you a snapshot of what we're going to cover today. I'm going to start by setting the table with some conceptual frameworks for how we think about automation and lifecycle management at Salesforce.org. We'll explore the functionality that's present in CumulusCI, our open source build and DevOps tool. We'll walk through a demo showing how to apply CumulusCI to real workflows and go from zero, a starting point in the Salesforce DX project, to a fully automated managed package release in about 10 minutes. We'll talk a little bit about how to use CumulusCI in continuous integration with our application MetaCI, and we'll look at the portable and portable automation, how to take this lifecycle automation and build automation and expand its scope beyond continuous integration to benefit all of your users. I want to start by taking cost off the table, at least part of the way. CumulusCI, MetaCI, MetaEcho, and MetaDeploy, the 4 applications I'm going to share with you today, are 100% free and open source. We are a team that loves participating in and supporting the Salesforce open source community. So you won't have to pay to use these applications as such. Caveat, of course, is that you do need to pay for any server infrastructure that you consume from providers like Heroku, CircleCI, Jenkins, and so forth, and any Salesforce licenses that you use in your production Salesforce org. But the tools and techniques that I'm going to show you today come without cost, and because they're open source, you're free to inspect the code, see how we've built these tools out, contribute yourself, and extend them for your own use cases. And that's something that I think is really exciting. All right, let's dive in to the conceptual framework around portable automation and talk about the trail to production, the shape of the application lifecycle. I'm going to divide a basic schema of the application lifecycle into 5 stages here, starting on the left with initial development and ending on the right with deployment, when you bring something you've built to your end users. Now, of course, when you're building a real Salesforce application, it's not a linear process. It's more like a complex set of threads that braid together and loop back on themselves as you iterate, as you develop, as you bring things forth and consume user feedback. But I think this is what it boils down to along each of those threads of work. And what I'm diagramming here is 5 stages that I think you'll find in any application lifecycle, whether you're an end user of Salesforce and deployment ends in your production Salesforce org or orgs for your users to operate on, or you're an ISV and production is your packaging work for the managed packages you're shipping through the App Exchange, or you're a consultancy and you operate in kind of a hybrid of those models across many different clients. So we start on the left with development. And the roles that get started first in the application lifecycle are your developers and your admins creating features in some Salesforce org or another, hopefully an environment that belongs to them and that they can use. As features are built for your application, they go through a testing process. You'll bring in another role, a QA engineer perhaps, who sits down with features that you've been built, ideally, again, in their own environment where they can test those features out in isolation, make sure that they meet your acceptance criteria and the standards of quality that you expect for your end users. As each of those features gets developed and it moves through the initial 2 phases, it'll ultimately end up in a merge phase where you want to take that feature work that you've built out and include it in the main line of your application, move it into a release candidate, so to speak, to get it ready for shipping to your users. If you're operating in an environment where you use source control, this might be an actual Git merge, or it might be a deployment of metadata into an integration sandbox of some type. Either way, you'll bring in that new functionality, and then you'll start through another testing phase. You might call it different things. You might have multiple testing phases, say an integration test, user acceptance testing, or business acceptance testing. You might also do something like a performance test or a load test, or other types of evaluation before you bring that release candidate out to your users. So again, we're bringing in some more roles here. We have QE engineers, we might have end users or business users sitting down to evaluate your features. And ultimately, when all these tests pass, you're going to end up in a deployment. You're moving to production and bringing in more roles, end users, demo engineers, support technicians, product managers, other folks who are involved in the lifecycle of your application. Underlaying all of these roles that are filled by persons on your team is another role, the continuous integration system. If you're using one, and if you're not, we'll look at how to make that more accessible and valuable to you throughout the course of this presentation. That is an automated system that's operating at every stage along the trail to production and doing some things that turn out to be relatively similar to what your team members are doing. I want to call out that question as a key entry point here. Where are these participants in the trail to production doing their work? Well, they all need a Salesforce org to do their work in. And that turns out to be a commonality, not just among all of the user roles on your team, but also the automated systems that you're using in continuous integration. To do work on your application, you need a Salesforce org, so you need to step through some pretty similar operations. You create the org, configure the org to meet the needs of your application, deploy the application, potentially do even more setup automation that's specific to your application and to your role in developing that application, and then you do work in that org. The problem, of course, is that these steps can be very expensive and very challenging, both in terms of money, time, and investment of your team's labor in building out that automation. So one often ends up in situations where a continuous integration system, for example, is using a single persistent org, or users are stuck sharing environments that might be out of date or inconsistent or in conflict with one another. This is what I call the org problem. And the org problem comes out of a couple of key technical constraints. One is that building new orgs is hard, and the other is that managing the state of persistent orgs, like developer editions and sandboxes, is also very hard. Traditional tools that build orgs often only do metadata setup. They may not do things like application configuration, data seeding, dependency management, other types of setup. They may not provide functionality for you to create multiple org shapes for the different roles on your team, developers, admins, app builders, testers, and on down the line. And automation that you build and invest in your continuous integration system is usually not portable. It's not usable outside the confines of that system, and it can't be consumed by your users. The org problem comes with some consequences. Two of the chief consequences here are loss of velocity, because your teams are hamstrung by poor infrastructure, but perhaps even more impactful, loss of confidence. It's hard to be confident in the results of your application's testing when you don't have repeatable setup, when you can't operate in clean environments. You end up chasing red herrings, going down rabbit holes that aren't productive because you can't be sure of what you're seeing. You don't have a clean test setup. It can also be challenging when you're facing the org problem to implement modern best practices like source control, Salesforce DX, and a cohesive application lifecycle management program. And often the alternatives to solve these problems are too limited, or they're very expensive, or require specialization on your team that you might not have available. I want to turn now to having laid out the org problem as a challenge that's common to many Salesforce operations. I want to lay out the Salesforce.org solution that we've adopted and built for our own use as we create and publish to the community many large, complex Salesforce applications. That solution is called Portable Automation, and CumulusCI is the tool that we use to implement it. The basic framework of portable automation is threefold. We start with version control as the source of truth, and Salesforce DX scratch org as the location of work. If you've worked in Salesforce DX before, or if you've done some of the trailheads that you'll find on Git and GitHub and Salesforce DX, these concepts are probably familiar to you. Metadata needs to live in version control as the source of truth so that it can be deployed into many different Salesforce orgs. If it's not in source control, it's not real. It's not part of your application. Salesforce DX scratch orgs are an incredibly valuable tool because they provide clean, reliable, disposable environments that each participant in development can use in isolation from one another, without conflict, without infrastructure bottlenecks. But the challenge is that building a thoroughly realized Salesforce DX scratch org is quite challenging and involves a lot of different skills and components coming together. That's why we have the third component of this triad, CumulusCI as the automation engine. CumulusCI is what makes it possible to create complex, thoroughly realized Salesforce DX scratch orgs easily for every role and every member of your team. We call this portable automation because it goes beyond continuous integration. It's automation that can be consumed in many different contexts by many different people who are involved at each stage of the trip to production. In particular, we have 4 different applications that all consume the same portable automation. The first is CumulusCI, CCI, the command line tool that our developers use. The second is our forthcoming web application, Metajo, which we'll look at later in this presentation, a web application that's designed to make it possible for admins and app builders to use clicks, not code, to interact with portable automation, Git, Salesforce DX, and source control. A third is MetaCI, our web application providing continuous integration that's tailored for Salesforce applications. And a fourth is MetaDeploy, our customer delivery solution that you might be familiar with if you've browsed to install.salesforce.org. Let's talk a little bit about what CumulusCI actually does when it's creating these complex scratch orgs for you. I like to divide CumulusCI's functionality into 3 broad buckets. First of all, it builds orgs for you based on repeatable recipes. Every time you create an org of the same type with CumulusCI, you should get the same result, a fresh, clean environment that's ready for you to do work. CumulusCI comes out of the box with a wide variety of functionality that you may need, including dependency management, installing the managed packages that you require, deployment of your application and other metadata that you might need to do your work effectively, and seeding your scratch orgs with data. Once those orgs have been built, CumulusCI also provides tools for each role to use in their orgs, whether that's running tests, Apex tests, or browser automation tests through Robot Framework, deploying and developing code and metadata, wrapping the Salesforce DX tools, building atop the Salesforce DX platform to make it easier to use and more effective for your developers, and loading, modifying, and capturing data sets that help fully realize and round out those orgs, make them look real, and give you a user experience throughout your development lifecycle. Thirdly, CumulusCI provides tools to orchestrate the entire development process, running continuous integration builds. If you're an ISV, releasing managed package versions in an automated fashion or a manual fashion, however you prefer, and helping you manage your application's branching model using what we call CumulusCI Flow, a flow that's tailored to building large, complex Salesforce applications using version control. CumulusCI does this by composing elements called flows and tasks into complex automation. Tasks are simply units of automation. We ship dozens, perhaps hundreds of tasks in CumulusCI to execute many common operations for you out of the box. Flows are ordered sequences of tasks that achieve some cohesive goal. Flows and tasks may be composed further into flows that you build and customize for your application to achieve your specific needs for the roles that are part of your operation. But we ship CumulusCI with dozens of flows that suit many different roles across the Salesforce application lifecycle. Here's just a small example of the tasks that we offer out of the box. You can do deployments, you can do data seeding, run unit tests, capture changes, install managed packages, run browser automation, and much more. And if you find that there's something you need that we don't provide out of the box in CumulusCI, it's very easy to add new capabilities with a little bit of Python code that can interact easily with any Salesforce API to get done what you need to get done. We define this composition of automation in CumulusCI using a simple markup language called YAML, an example of which I'm showing you here. Automation is defined in a text file that lives in your source code repository called cumulusci.yaml. And this is an example of a flow that builds an org with very specific requirements that comes out in a complex configuration suiting a particular role. In this case, that role is a trailhead learner who's trying to execute a specific module. I've here composed 5 different elements of automation, 4 out-of-the-box tasks to install the dependencies of the nonprofit success pack, deploy some extra metadata to provide record types, create an additional record type in the org, install the application, and execute another custom flow that I built that does complex data seeding and user setup. It achieves a complex end, but it's really quite easy to plug together these simple units and building blocks of automation to get where your users need to go. And I'd like to make that concrete by showing you a hands-on demonstration of a real CumulusCI workflow. So I'm going to swap windows here. And what we're going to do in the next 10 minutes or so is we're going to go from a Salesforce DX project, I'm showing you a DX project here, to a fully automated managed package release, stepping along the stages of the application lifecycle. We're starting here with a food bank application. This is a mock application. It's very simple. It's built on top of the nonprofit success pack, and it's modeling some objects that a food bank might need to use to track deliveries of food and food items that are being brought to them. So you can see we've got a Salesforce DX project here. It contains a couple of objects, some custom fields, and not much else. And we're going to use CumulusCI to build this into a managed package that harnesses the nonprofit success pack and extends it, and step through the process of testing and releasing a version of that application. So let's get started here. First of all, I'm going to initialize a CumulusCI project in my GitHub repository.
David, just one thing. Are you going to share this slide after the presentations? We have a lot of questions regarding that.
Yes, I'd be happy to share this.
Thank you.
So we're going to start out this project as a managed package project. We'll walk through a simple question and answer wizard here to define what we want to do. And I'm going to answer yes to this last question here. I am going to extend an existing CumulusCI project. I'm going to extend the nonprofit success pack in particular. This is an easy way that CumulusCI makes available to you to consume automation that already exists in another project and get that value in your own application. If you are building multiple applications, you can consume automation across those repository boundaries to build out a complex suite. You can see here that CumulusCI has added some material to my repository. In particular, it's added a cumulusci.yml automation file, some scratch org definitions for me in different shapes, and an example robot browser automation test that creates a contact to make sure that I can still execute some of those basic Salesforce operations. Let's get started by taking a quick look at that automation definition. You can see here, if you were following my interview with CumulusCI, that my answers are represented here. I've declared a dependency on the nonprofit success pack, and we'll walk through in a few moments what exactly that's going to do for me when I create an org. And I've also got some pre-built test automation here that will run the robot tests CumulusCI built for me in my repository and make it possible for me to get started with that browser automation, which in the course of my application's development, I'm going to extend and make more sophisticated so that I get real click path testing as well as Apex unit testing. Let's move on and go ahead and create a Salesforce org. And I'm going to accelerate the build process here in the video that I'm showing you. I'm going to run a flow called dev.org against one of the scratch org definitions that CumulusCI created for me. And CumulusCI is going to do, this is out of the box. I didn't have to do any work to define this flow. CumulusCI has gone and built out a scratch org for me that contains all of my dependencies, my nonprofit success pack, all the setup automation that the nonprofit success pack needs, and then deployed my application into that scratch org and made it ready for me to use. Let's take a look at what this actually looks like. Dev.org is a flow that our developers at Salesforce.org use every day, and we ship it as part of the standard customization for CumulusCI so that you can consume it as well in the early stages of your application's development. We're in that first stage on the left, the develop stage and the testing phase, because we're going to test out this application here in just a moment. You can see that just by including that dependencies declaration, I've got 6 managed packages installed here, which have a complex set of dependencies between them. CumulusCI has automatically resolved those dependencies for me, installed all those managed packages, and made this org ready for me to use. In addition to satisfying all of my dependencies, we'll see here in Object Manager that the 2 custom objects that I built out as part of this Salesforce DX project are present, the delivery and delivery item objects, just as you'd expect them to be. And further, if I go and look at the account object, I'm going to find that not only have I had managed packages deployed as my dependencies, I've also got setup automation. My setup automation created these 2 record types for me because that's what the nonprofit success pack needs, which I'm extending and harnessing as part of my food bank project here. All that comes out of the box. It's part of CumulusCI's native functionality. My org is now set up and ready for me to use. I can begin developing or I can begin testing in this org. Let's look at an example of what the next stage might look like, the testing stage. I'm just going to go ahead and run the robot test that CumulusCI built for me. It's out of the box. And this test doesn't test all that much. It tests that you can safely create a contact, so you haven't broken some of that core Salesforce functionality. But it's an example of the browser automation that I can extend and use to make sure that my application not only passes all of its Apex unit tests, but also works well with real user click paths, an end-to-end test done very early in my application's lifecycle. I'm not clicking here, you might notice. The browser is being driven by the robot framework, which does browser automation based on Selenium. It's creating a new contact in an existing household here that's already been created through the API, which you can also interact with in robot. And I'm going to see in just a moment that my test has passed. My application hasn't broken that core Salesforce functionality. I've got a pass. And we're going to take that as a simple proxy for our ability to move on to the next stage here. The next stage is merging into our main line. And I'm going to do that using a continuous integration oriented flow called CI master. CI master is going to execute very similar automation to deploy my application into my packaging org. I'm an ISV here. I'm building an application for food banks. And we're going to deploy this new feature into that packaging org so that we can perform a release, a beta version of our managed package that we can then take to further stages of testing, integration and acceptance testing. So I'll run one more CumulusCI flow. This again comes right out of the box to release a beta version of this managed package. CumulusCI talks to the Salesforce API for you, mediates this whole process so you don't need to go into your packaging org and perform an upload. And this is something that you can choose to automate in your continuous integration system if you wish to do so. At Salesforce.org, we release a managed beta every single time we do a merge to master in our source control. It's a key part of our process that helps us develop high quality applications by getting a user experience early and moving our testing left so we can catch bugs far before they become expensive and before they reach any of our users. CumulusCI makes it easy to adopt that kind of workflow where testing is embedded at every stage along your application's journey. So we've just released a beta version. It's been, what, 8 minutes or so since we got started here, and we've released a managed package. In addition to doing the release, what you can see here is that we've done some GitHub automation as well. I've actually created a release in GitHub and built out some release notes from all of my pull requests that automatically aggregates that information. So all the people who are involved in my application and my whole community, if I'm an open source project, can see the work that I've done without me having to invest any additional work in communicating that out. All comes for free out of the box with CumulusCI. I'm jumping to the next stage here. We've built a beta managed package. We need to do an integration test. So I've deployed an additional flow here called install beta. And install beta is building me another scratch org. It's a different type of scratch org this time, a beta org that's intended for testing a release candidate. Let's dive into that org. I'm going to use the CCI org browser command again to open this up. And a feature that I want to call your attention to as we dive into this org is that I still have my developer scratch org open and available. The developer org that I started working in and the beta org that I'm going to do testing in here are completely independent of one another, and I own them both. They're my unique environments that are configured to my needs. No one else is using them. I have no risk of overwriting or conflicting with anyone else's work. And I have 100% reliability. I know that every time I create this org, I'm going to get the same results. So I can be confident that what I do in this org is repeatable and reliable. And in this case, in a beta org, it's reflective of what my users will see as well. So I can be confident that I'm ready to take this application towards production if my testing passes in this context. We can see again that we've got the Nonprofit Success Pack installed and all of its dependencies, but we've also got our food bank demo app installed. This is version 1.3 beta 3, and that's the release that we just created a few moments ago. We can get hands-on with it right now in this beta org by diving into our deliveries tab. And we can get a real user experience here. And one of the things that we love to do with our applications, which I haven't done here for time reasons, is I'd love to sit down to this application and see this tab fully populated with deliveries, with accounts, with contacts. That's something we do in CumulusCI too, via data seeding. And we make it very easy to create a data set that you can automatically inject into these orgs to get that fully realized end user experience. All right, that was a very quick demo, but I think it's a great illustration of what CumulusCI can do out of the box with very minimal additional configuration. We went from a Salesforce DX project to a managed package release that we can test in a user-like environment in right about 10 minutes, and all that comes out of the box with CumulusCI, but can be further customized and extended to suit the specific needs of your development team and your application. MetaCI is a way that you can harness this automation potential and make it part of your application lifecycle all throughout the stages. MetaCI is our in-house continuous integration application that's designed specifically for Salesforce products. It is also free and open source. It runs on Heroku, and MetaCI makes it very easy to orchestrate your development workflow by running CumulusCI flows in response to changes to specific branches and tags in GitHub. It helps you report status back to GitHub, just like any continuous integration system, but it also helps you harness that CumulusCI functionality to track and create releases, automatically generate release notes, and much more. Now, all that said, I also want to emphasize that these are open source applications. They're designed to be used independently or together. So if you prefer to use a different continuous integration solution like GitHub Actions, CircleCI, Jenkins, an on-premise server, that's just fine. You can use CumulusCI as a build tool within that context, no matter what your infrastructure looks like. And I want to give us a look back at the trail to production here as well. We've seen a few of these flows hands-on now. We started out with development and built a dev scratch org with the dev org flow. We ran the robot test task against our developer org to do the feature test sequence. We performed integration using CI master to deploy into our packaging org and release a beta managed package. And then we did an integration test step using install beta. We're now at a stage in this application's lifecycle where we're ready to do a managed release and run the install prod flow to build a scratch org that looks like a real customer, an end user production Salesforce org.
David, a quick reminder that we will be starting the QA in another 5 minutes.
Absolutely. We're getting there in just a moment. I want to talk a little bit about portable automation beyond continuous integration and beyond the CLI, because there's folks on your team who may not wish to use the CLI. I'm very excited about Metaco, another application in our suite that is forthcoming. It is under development. Metaco is a web application that makes it easy for admins, app builders, and other declarative users to make use of portable automation. With clicks, not code, you can create orgs according to shapes that have been defined in CumulusCI automation, capture work done in those orgs, surface it for review to other members of your team, as my work here is being made available to Jason Lance for review in his own separate org, and then easily take that work into GitHub without having to know how Git works. Generate a pull request from any sequence of work that you define as a project and task in Metaco, and make it available in GitHub as a PR for the team to review and incorporate into your application. I think this app is going to be transformative. I'm incredibly excited about what Metaco can do to make source control, Salesforce DX, and portable automation available to admins and other users on your team. That is a forthcoming application, and it will also be open source. I also want to briefly introduce you to MetaDeploy, which is our customer delivery solution. Also a free and open source Heroku application, MetaDeploy is the technology behind install.salesforce.org. It allows your customers to directly consume your portable automation in a bring your own org scenario. Customers authenticate with their orgs in MetaDeploy, and then they are able to make use of smart product-oriented installers that deliver your application using portable automation. So you don't just install one app and then hand off a 100-page setup guide. You can actually execute that setup for your users in their orgs and allow them to consume that same automation that you've designed for your users to make your application lifecycle look great. Let's circle back quickly to the org problem as we wrap up here. By applying automation throughout your application lifecycle, you can get some really significant benefits in solving the org problem. The first and perhaps most important is increased velocity and confidence. By using portable automation, you no longer are bottlenecked on shared infrastructure, and the results that you find are repeatable and reliable for everyone, developers, testers, and end users. And not only are modern best practices baked into portable automation, they're enabled by portable automation. They're made more valuable by portable automation. So you don't just get source control in Salesforce DX. You're not just required to use Salesforce DX and source control, but we actually make it easier to consume those technologies, and we increase their value by applying them throughout your development lifecycle with portable automation. Users get access to holistic environments that encourage collaboration because CumulusCI makes it easy to capture and share work, no matter what your role is or what phase you're operating in the application lifecycle. And with Metaco, our forthcoming web application for portable automation and Salesforce DX, you can bring admins into the source-based development lifecycle without requiring them to use and learn a lot of complex new tools. They can use clicks, not code in an environment where they're very comfortable while still participating in a best practices development lifecycle that's also developer friendly. Most important of all, of course, it helps you deliver great applications to your users and make sure that you're delivering the quality that they expect and that you need. So that's the takeaway message that I really want to leave you with. CumulusCI makes sharing and collaboration easy, whether you're in a single organization, working across organizations, operating between roles on a team, or participating in the open source community. And I know there's some questions in the chat about how to learn CumulusCI and what resources we have. I absolutely want to point you to our new trailhead, which we just released a month or so ago. It's called Build Applications with CumulusCI. It includes 6 modules, and it'll take you from the very beginning where you set up and install CumulusCI on your computer to the end where you'll release a managed package and then build out additional customizations on top of that managed package. I helped write this trail. I think it's a lot of fun, and I really encourage you to give it a try. We've got some more resources as well that you can take a look at. CumulusCI's documentation is public on readthedocs.io. You can find us on the Trailblazer community or in the Power of Us hub. If you don't want to try to copy that URL, just search for CumulusCI on the Trailblazer community or the Power of Us hub. You'll find us there. We are an open source project, so you can look at our public repository on GitHub at sfdotooling/CumulusCI. And because many of Salesforce.org's products are open source and use portable automation, you can look at the best practices that we've created in applications like NPSP and the Education Data Architecture, and you can apply those back to your own apps. Further, because of the Open Source Commons project, you can look at SFDO community and see other applications that the community and our open source sprint participants have built using portable automation, and get inspired there and find great techniques that you can apply to your own builds. Thank you so much for coming to this session. We have a few minutes for Q&A. I'm really excited to hear what you are thinking about in terms of CumulusCI. Let's see, I'm gonna look over here at our question and answer, and let me see.
Would you like me to read out the questions for you?
Certainly, go right ahead.
Okay, so first question is, how easy or fast can I achieve inserting opportunities with accounts and opportunity products into an empty org with CumulusCI?
That's a great question, Zandor. And of course, the answer depends heavily on your data volume. One of the key features of CumulusCI's data infrastructure is that it works at any scale from 1 record to 80 million records. If you're looking at loading a couple of dozen records in those S objects, you can do it in just a few minutes. We offer tools that let you generate a dataset mapping to define what data you're interested in extracting and loading, and then run the tasks load extract dataset and load dataset to pull that data out of an existing Salesforce org and load it up into your Scratch orgs within about 10 minutes or so.
Okay. Does Salesforce recommend using CumulusCI versus other CI apps like GitLab CI or CircleCI?
That is a great question, and I want to make a key distinction here. CumulusCI itself is a build tool, an automation tool, not a continuous integration system per se. You can use CumulusCI in any continuous integration system. Of course, we recommend MetaCI because we built it, but if you have different needs than we do, you might prefer to use CumulusCI within the confines of your own on-premises Jenkins solution or in GitHub Actions. And if you look at our documentation, we've actually got a cookbook showing you how to use GitHub Actions on an open source project with CumulusCI as your build tool.
Okay, I guess this is regarding the demo you were showing. Can you show the place where the packaging or configuration is mentioned in the scripts? Are the commands you are running available for all the users of CumulusCI out of the box?
Yes, everything that I showed you today is available out of the box with every CumulusCI project.
Awesome. Can you do the package dependency management for deployments into a production org as well?
Yes, absolutely.
Okay, one question is that you are going to share the deck and you are also going to share the code for the demo that you have shared. And where will it be shared?
Absolutely, you can find that on our GitHub or on my own GitHub. I'd be happy to share that.
Thank you. Does CumulusCI only work in coordination with Salesforce DX, or would it work with other commonly used Salesforce Devtools?
CumulusCI requires Salesforce DX.
Okay. CumulusCI is equivalent to Jenkins and deployed and adapted for SF applications?
Not quite. You can think of CumulusCI as a tool that you could use in Jenkins or in any other CI scenario to add orchestration on top of Salesforce DX, or to replace an older build tool like the Force.com migration tool in Ant.
Will Meteco work with in-house Git repositories as well instead of GitHub?
Currently, all of our tooling requires GitHub. We're really excited about the possibility of adding support for other Git infrastructure like Bitbucket and GitLab. And if that's something that you're interested in, we'd certainly welcome community contributions.
Can we use CumulusCI between sandboxes and productions, or we need to use always Scratch orgs?
We strongly recommend using Scratch orgs. You can use CumulusCI with sandboxes, but you don't get as much power and value.
Okay, does CumulusCI help alliterative limitations around deploying metadata that still exists with Salesforce DX?
Absolutely. You can use robot browser automation to get around areas that are not currently deployable by scripting the Salesforce user interface to execute configuration steps that are not metadata API accessible.
Okay, there is another one question. When Meteco will be released, next month, next year?
Great question.
I guess someone answered it. That is part of the new source tracking solutions to be part of Salesforce, hinted in Summer 20.
No, Meteco is an independent application. It's not linked to Summer 20's sandbox source tracking solution. I don't have a release date. We're really excited about getting it out to the community, but I can't make you a promise on that today.
Okay, does it work with Tortoise SVN?
No, you have to use Git.
Meta UI can be used on Sandbox, or it has to be only with SFDX?
We strongly recommend using Salesforce DX and Scratchworks. Some of the tooling in CumulusCI will provide you with value in the sandbox-based ecosystem, but we do believe that the application lifecycle that we've defined and use Scratchworks for provides the most value with CumulusCI.
Okay, so to use the CumulusCI, does it require Python knowledge?
No, you can use CumulusCI with no Python knowledge whatsoever. If you want to extend and build upon CumulusCI, you can use Python to do that, but you can consume all of the out-of-the-box functionality and build your own custom automation using the tools that we provide using only YAML text markup. No programming knowledge is required.
Okay, can we use Bitbucket instead of Git?
We currently do not support Bitbucket. You can make use of some of the capabilities of CumulusCI in a context with Bitbucket or GitLab or any other Git provider, but the automation that we provide that is specific to the Git repository does require GitHub. We would love community contributions to help us support other Git providers.
Okay, Naresh, I know you would like to see where these configurations are mentioned in the script, but we are running out of time. David already shared his contact details, so you can maybe reach out to him on Twitter.
Thank you very much.